It's aiming to derive several clusterings for a few datasets and to see how it works and how can it be affected by the changes in the user panel and so on. Let's get started with the structure of the package when you unzip it. This is the only guy who can be actually deleted. Everything else is being used during the flow and it can't be even renamed. So please keep the naming and everything as it is, because the flow itself is counting on that. The data is the folder when you have to put your actual data for the clustering and test part. Finally, this guy is something which is helping to see how efficiently the flow can deal with wrong data, noisy data, messy data, and unstable data. So this is the reason why the naming here is the messy POS sample. If you are interested in the data description for especially customer journey, you can find it in this folder. So please, once you have your data, just put it in the data folder and you are good to go. Segmentation for now for this release is dead. As was mentioned, basically the graphical schemes and the package itself is in a very baby version, which will be extended in the next release as the whole code of the Python will go here. Then another part is SQL and SQL script. This script is tailored to the customer journey data, which are part of the package data folder. So once we will have good understanding of the data, we can write a business logic SQL script, and that SQL script is being called at the very end of the business insight dashboard. So first we will use all the machine learning setup, derive the clusters, then we apply these clusters to our out of time test, and once all of that makes sense for us in regarding the business and statistical logic, then we can store the results of this production test and apply another part, SQL business, and derive these statistics like LTV, LTS, insurance, and so on. So the SQL folder and your SQL script is being called from this folder. And finally, the output are the all outputs during the flow. It is in the README, so analytical output is connected with the part, I believe, 2 to 7, which means that all the dashboards, all the graphs and everything, the pages which are generated during the flow are stored here. With respect to the naming and everything, we'll be talking during the flow. Business analysis, that's for part 8, all the generated graphs and dashboard. Models, that is all the derived clustering models, imputation, hashing functions are fit and stored in this folder. Again, there is a specific naming which I will be talking about soon. And score data, which are your original data from the data folder, extended by the clusters, which means, for each ID there is a given new cluster, and also for the test part, for the test data, it's extended by the outliers. The training data are not extended by the outliers because we clean training data by the outliers, so there is no outlier from that point of view. Files, we can see it only one file, and that is the main UI, this whole flow and the code. And finally, the versions of packages which are at the release. So let's just load the packages to the memory. Please again be aware that this has to be specified to your installation folder or path. It is connected with this graphical visual for decision tree, very nice histograms and distributions of the features which are behind your clusters. This warning is connected with the fact that we are using the last iterative imputers, and they are still under the development at skitlearn and the experiment. So what about the user input? If you will provide very bad data to the clustering, it will simply end in very bad way. But when I was building this flow, I knew that, and I really tried to use as much as, let's say, automated solution as possible And the cleaning part in the data here, it's all about that, to provide you maximum space, maximum comfort, that it will try to detect, let's say, if you forget the phone number or ID. So this is the number 3 harmly high variance, and I try to build a function which is able to detect it and automatically remove it, because we know that objective of this is not to harm the clustering but to build a good clustering. But it can be used simply for the explanatory analysis. You don't have to even think about it as the clustering. You can use this flow as an explanatory analysis of your data mining, and it will give you a lot of insight about data quality, correlations, and also stability of your data. So this can be seen as an independent module here. The decision maker is always a business insight. Thus, these dashboards here in the training part, number 5 and 0.7.8, which is basically one-to-one just on the out-of-time sample, and this is a training part. We are using the original variables to provide you the let's say ultimate insight immediately on the train, if it makes sense for you or not regarding the business, how you understand your data, and what you need from the clustering. Then there is another step. And when I was talking about the version 1 with a few of you guys, it wasn't always clear what is the step 8, the business insight, and how it actually differs from the dashboard before. So the business insight is here you are still in the statistical space. So even though that I'm trying to highlight here, we are using original values, you are basically checking if the all applied statistical methods did a good job and generated well separated clusters with some basic business insight. But still, it will not give you the ultimate answer how it will work on the production, and do they really differ the way that we need it to be differed. And the fact is that there isn't a little trick. We can do that. We can find the ultimate answer. Is this a production game changer? Is it really worth it to, launch this guy on the production? So the business insight part 8, it's all about that. It is independent flow, as out of time sample is independent flow, as you can tell. This is a production flow. So basically, once you train your sample and you store all the training fitted models, then this flow can be copy pasted to your production. Just all you have to have is Python, and it will automatically read all the stored models from this output model directory, and it will score your daily production. It is built this way, so it is not only out of time sample flow or part, it is also production part. And the business insight is, before you do the actual launch on your production, you need to be sure that the build clusters have some real business sense that you can talk about with your colleagues. So I'm having clusters assigned to each ID, and now I'm going to do that for each cluster. I'm going to compute a business statistic. To do that, I need my SQL business logic script, which will derive all of these guys with respect to the structure of the original data. So if you want me to be very explicit, obviously this whole SQL script is starting with the fact group by segments which were just derived, and the automated name in the flow for this version release is sec k-means. So it's all of it, it's group by that, right? So now I believe it's very clear. And then it will provide by ID clusters all these business logic. And that is the reason why I'm saying this is the actual decision maker, because first of all, we will not start with any logic regarding business logic. We will use this tool as an explanatory data mining tool. Let's assume that we are assigned as a data scientist, let's say, to do a data mining, or we are dealing with a new department or new data, and we would like to understand the structure of the data, if there are any extreme values, if there are any inconsistencies, instabilities, what is the unique information, and so on. So what about we will think about this flow now as a automated exploratory tool, and that is one of the purposes of this tool. So training data and test data, I'm keeping them same naming. Why am I doing it? It's a nice trick, because in a training we are going to eliminate all the outliers. So the scaling, the standardization, and the training for the clustering, it is not affected by the extreme values. On the test data, if we are using the exactly same data set, we are keeping by the definition the outliers, and we are using all the fitted things from the training part on this test. So it will give us the insight where the outliers are being concentrated by the clusters. So it can give us very good insight what is actually happening with our data and why. Okay, so let's do it as a exploratory analysis. So we are keeping the same data set here. Machine learning setup, I would keep it the same. As missing rate, I generally consider 70% as something reasonable. I know I've seen many times that people are using 50, so I believe it's up to you. The modus share, I would keep it to 90%. In other words, what is the maximum share of one value among all the values of one in the particular variable? I would say this is pretty already high, like a constant value, so not necessary to stay in the data set for the training. Maximum correlation, I think 90% is pretty fair regarding the similar information between two variables. Outliers detection, I would say I always see it as a like multi-dimensional tail, so 10% cut it from the older tails. I would say again it's something reasonable. As I said, this is very much connected with the scaling and try to make the standardization as focus on the majority of the population as possible. Categorical variables, let's keep it. I'm using hashing function, which is basically compression function for one-hot encoding, and the in this case the 500 variables are pretty okay here. I will use these in the imputation of the numerical missing values. Why not? Because it can be pretty handy for that. Maximum numerical dimensional, I think 100 is something like for me maximum, because I don't really think that even though that we are going to have like 350 variables, the more than a third of them will have a unique value. So this is really a maximum for me. And I definitely will going to use UMAP as I'm recommending here, as I really believe this is extremely extreme improvement in the whole machine learning society. Here I will use definitely PCA dimensional recommendation. The UMAP itself have a hard time to detect what is the optimal number of the dimension or the features. So if I have 300 variables, I need to reduce it somehow, and the UMAP needs some a priori dimensional input. So I think a good decision or good practice would be use a principal component analysis, which is a linear technique, and let's say if linear technique can extract 70% of the variability, in other words the information inside the data set, then that can be considered as the maximum value for non-linear, much more efficient as UMAP is. So we will use this recommendation, and that will be a dimensional demand or dimensional request that UMAP will extract the information to the dimension D. So business insight, what about minimum clusters? I would say 4, it's really a minimum for any business reasoning and let's say distinguishing groups within the data, and the maximum I wouldn't consider more than 15, and that space maximum 15 is there that it will be explored statistically in the bagging samples. If let's say from 1 to 15, what is the optimal number of clusters? And as I'm on the development, I'm not going to store it any soon. I will play with the data and I'm on exploratory analysis. So perhaps I can be changing these and these and these. So I will keep override result 1, which means once the data are fitted, they will be overwritten when I run it for the second time. It will not. Otherwise, if I will keep 0 and in the folder models here, there will be already stored and fitted models, then it will not do the fitting again, but it will rather load it to the memory I use that stored fitting. So I mentioned previously that I will be talking about it, how this works regarding the naming and so on. This is my testing folder. or development folder, and I already run here this testing message for sample. And you see that the flow itself in this model output, same structure, is generating 12 items. Some of these are very tiny, 1 kilobyte, and some of these are bigger. And it can be even over 100 megabytes if your data are really big and you are using hundreds of variables. This is imputation function, and this is UMAP dimension reduction space, how to fit that model and how to do it on the new data. So we have three keys. Primary is the train data name, then it's all about categorical transformation. And then it's actually the last element here is always the name of with a specific part, like transformations, standardizations, clustering fit, and so on. And obviously, if I set up here one-hot encoding, what will happen here? This guy will be stored and named this way, like this. Okay, and if I will change this, that I will not use imputation of the numerical, then this guy will be named as this. So now I think it's very clear. Why is that? Why am I using actually 3 keys that can, like, generate size of your models directly? I will rephrase it. I don't think that after you run many iterations and playing with your data with the given data structure, that you will most likely keep this fixed, constant. Like, there is no much reason to really change maximum missing rate once you will decide if it's 70 or 50%. There is no much reason to change maximum correlation. It can be, I would say, 90 or 95%. Also for this guy or this guy. So maybe on the very beginning you will play with this, but once you will see let's say the patterns in your data, then you will keep it same, because there is a lot of sense to keep it same, or let's say the best practice. Then what about the numerical variables? Again, UMAP is so powerful and so efficient in the way how it can extract all the significant and unique information from the variables and generate the new space of the variables with the dimension of the UMAP vector D. Then I don't really think that you will change it much once you will see how powerful it is. Okay, but once you will convert and you will see how it works, I strongly believe you will keep it fixed. So my assumption is this sooner or later will be freezed, this will be freezed, then number of clusters, maximum I don't believe you will change much. This is the space for the statistical explanatory analysis, and the minimum is driven most likely by your business decision. So sooner or later, these guys, the hashing and one-hot encodings, to me it's something that maybe for the particular reasons you will prefer one-hot encoding. So that's the reason why I'm thinking, well, maybe for the production or the, let's say, convergence purpose, you are willing to keep or store 2 different setups of the models, and that can be one-hot encoding or hashing, and that will generate and store different models here. Everything, these 12 features, 12 stored fitted information will be there again for different setup. Okay, so I hope this is clear, and now I will extend it a little bit, and that I promise is the last one regarding this setup. And that is that here it's implicit, maybe I should put it here before I will release this, and that is, I call it a num. And num means when you set up it like this. And I really like this again, it is kind of a little efficient trick. Why am I saying that? Well, I believe if you are doing data science for a while, you know that sometimes categorical variables can be pretty tricky, especially for the clustering, unsupervised clustering, because they are not directly measurable. And one-hot encoding, if we stay now on that guy, what is the distance, either Euclidean distance or cosine distance and whatsoever between 0 and 1? I believe we all see that it is not really that smooth as in the case of the numerical variables. And it can actually be shown, if you will play with it, that one-hot encoding in its original version, not hashing, doesn't really much help the clustering, especially the k-means. Of not using categorical variables help me to be sure that categorical variables transformation, it's not going to mess up my clustering. So during the exercise when I was building this flow and then deriving the machine learning clusters for Vietnam, I started with the base of only numerical variables, which I know they are well treated by any clustering algorithm by the definition. And then I plugged or extended that exercise and compared the results, how it behaves when I use one-hot encoding and when I use hashing. In other words, when I allow the clustering to see a transform categorical variables. Let's focus now on exploration and try to use the tool for the, let's say, unknown new data for us. And we will use for that sake our messy POS sample. We will keep a pure setup, which is there when you open the package, and I would consider that as something like best setup you can potentially have for unknown data. Just to see the structure, nothing else for now. So for that purpose we can just restart the kernel and run the whole notebook. So step by step we can go with the computation, and through that flow it will be discovering us a clues. So let's really assume that we just uploaded department which we never worked with, data, and this is our first look to our import. So we see with 300 variables plus minus, or let's say 350, we have around one sample, which is a random sample of 10,000 observations. And what we see here, it's some variables which naming is like code product, client time, and so on. So we can guess it is somehow connected with our clients and the way they providing data through some app. It seems like that we forgot the ID, so let's see what will be the data cleaning part result for that. And the good news is that the ID was immediately removed with the right determination that is probably ID. Also we see that with our machine learning setup there are many values which just keeping 90% of the share. So for that variable product channel, over 90% is dedicated for one value only, which can be considered as really kind of constant value with very low variance, very low added value for any exploratory analysis. So this kind of heavily missing part, it's over 70% missing rate. And then we see that it is true, this 90% share of only one value for these variables, which I'm guessing it's a call, so collections. And collections seems like they are pretty very empty variables. So we see that the majority of the variables which were removed are all about its excessive missing rate, or it is really not really informative variable. So this is the first clue here. Another part is that we see there is some significant correlations, especially in this little triangle here, so let's focus on that guy. And we see it is all about OBS. So again, as we know, this data are from underwriting, so this will be some variable which is information if there's something it's observable or not, with respect how the data are being collected. And you see that the correlation with the heat map, it's going sometimes close to 1. So warned by this heat map that we have pretty high correlation across all these OBSEs, so maybe we can consider to lower the correlation and continue. But anyway, let's just, as it's exploration now with like unknown data, then let's just check it out what it's going to happen with time stability. And what we see here that first these guys were removed, the OBSEs which we just considered as pretty high correlated, so maybe it's not surprising that if one was removed, then others will continue. Then we see something more here, so let's see what is going to happen on the graph. And for OBS this is pretty obvious that we have some average value 0.95, let's say, which is oscillating about it, and then somewhere at the end, or let's say third quarter or fourth quarter of 2019, it's going to value 0. In other words, if you know how the OBS observable variables works, it means that here it's nothing observable. Same for other guys. And obviously this is not stable behavior in time, right? So these variables, as we are using it for unknown data, it's clearly telling us these variables are very conditioned with time. Time is a function which is considered as a category and the share of the category. This is how we compute categorical variables. For numerical, it's the average, right? It's simple. And for categories, we take the biggest category and we compute its share. And we see that the share is oscillating around, like, let's say on average 50%. But then it disappeared completely, it's null. And then it appears and it's all just 1. So before, until the mid of 2019, it was about that some category had share 50%, and suddenly at the end of 2019 it is going to 100%. So it's become all about that category, this variable. If we are using the data for a clustering, for the business clustering, then this would mean that these guys, all of these, will be considered as specific segments, or segmentation will be somehow very much affected by these extreme structural changes of these variables. Threshold here, this is the threshold for the test. I set up it kind of like conservative way, in a way that I try to say if it's a little stable, I want it to keep it as a stable, because I don't want to be too restrictive. So you can tell this is not really stable, but if you look at it, that it became for a short moment unstable, and then it became again for a certain level. Then for the test which we're using, the Dickey-Fuller augmented test, this can be considered as a stable behavior, because this kind of shock happened only for a short period of time and it disappeared. So that can work. From here, from 0.2, this is really not stable, but again you can tell that it's coming back, like it's oscillating around like 0.2, then it jump up and it's ending somewhere around 0.2 again. So again, for the test, this can be considered plus minus as a stable. And the rest of the guys. And these guys are obviously very stable, right? You can tell that it's oscillating about some average stable trend line. If you are new with or not familiar with the stationarity tests or the concept, just imagine it as if you can use a trend line here, which will be flat, so then it means it's a stable stationary time series with respect to time. If the trend line would be increasing or decreasing, like here, or here, this is like, obviously if I use a trend line it will do something like that, right? Then it is not stationary. Okay, so these are very obviously stationary time series. These are on the edge of, let's say, our threshold. So if we change the threshold here, let's just move it little, go down like this, and rerun this guy. Then you see that only one variable is considered as newly, one variable is considered as not stable, that we decrease it, so now we are more conservative. And newly we have this guy determined and unstable. You can tell what something happened with the dashboard, right? So all the unstable variables before were already removed. Why is that? Because we already rerun the data which were cleaned, because I run it all. So as I'm saying here, all the unstable variables will be removed after this step. So once I already run this, it means that it removed the data, unstable variables, from the list of variables which are not anymore considered for the training. The rest of the variables are already eliminated. This is the situation. What about outliers? Outliers by definition, as we set up 10%, so the out population, it's 10% of the population. And is there anything we can tell with respect? Obviously the determined outliers have very different anomaly score. It's around average 2 instead of this guy is like less than 0, the average score for not anomaly, in other words considered as a inlier, not outlier. And there is some kind of little correlation with this axis principal component 1. As you can tell, it's going to the right and going to with PC22. So we can say, as the principal component is a linear combination of these variables and all of the variables which you have in the set, in our case 71 variables after the cleaning, right? But we are on the now set of only numerical variables, as the principal component is focusing on and outliers are focusing on the numerical set. We have 45 numerical variables here, and these 45 are behind all of these components, but not all of these 45 variables, which are like a linear combination and creating this component, are having a same weight. In other words, the biggest contributor, the guy who has the biggest weight, in a way that it's contributing to build the principal component 1, is this count of non-home credit loan open in last 12 months. The second guy is PCB count living, yes, loans, and this guy is PCB count in open loan in last 6 months. In other words, this first axis is telling us this is something about the profile of the customer in credit bureau in a recent time. Let's say we can use analytical aggregation. And principal component 2, it's mainly contributed by application form, credit amount, application form, tenor, and insurance. So I think this is very clear. This is the business setup or product setup which the guy is choosing when he's applying for his loan in home credit, and this is his profile. So now we have a clue that first axis is about PCB profile of the client, and the second axis is about the product he's choosing. And you can tell that the profile, in other words the size of the loan, I would guess, it's having some big outliers here, and also there is some huge outliers connected with credit amount choosing or tenor which is being chosen by our clients. So these guys who chosen extreme products with extreme, let's say, credit amount, or the guys who have extreme loans, open loans in credit bureau, they are considered as outliers and they'll just be eliminated. It doesn't mean that necessarily the data are wrong, it just means that these guys have so high values of some key variables that it will actually affect the whole standardization, the scaling for the rest of the population. And as we know, as you can tell from these little orange points, that it is only few guys, and these guys, as we are using average, would actually affect pretty much the average, or at least they have a pretty high tendency or potential to affect that, and that would affect the rest of the whole population. In other words, 90 or 95% of the people will be affected by only little population, and we don't want that for training clusters. So let's just take them out and clean the data, and let's say focus our research on the majority of the population. So we are keeping 90%. Categorical transformation, as we just chosen hashing, so we created hashing sentence, or let's say a categorical sentence, and this is just the theoretical dimensionality. But if we take into account how many categorical variables we have in our data set, then if we count each single category inside each categorical variables and we multiply it, it will generate as theoretical uncorrelated potential all the combinations among all the categorical variables. So if we are on some concentrations, then this value, which is the overall dataset length, total number of observations, which will be much lower because it will be concentrated, some combinations or certain values, right? Like here we see only 2, so there is hardly any concentration, as you can tell. As I'm like saying here, it is no compression really on the categorical sentence. So it is kind of, because the dataset is so small that it doesn't have a chance to show us the concentrations of some combinations of all categorical variables. So it's basically generated unique categorical sentences for every single customer. And I'm going to talk about this in the next sessions regarding the hashing example, how this works, and this is pretty informative. If we will run it for, as I tried it, for like 600,000 observations then this reduction, it's like 50%. In other words, there are huge concentrations of some combinations of categorical variables. And as categorical variables are describing our customers, we can tell something pretty interesting about the customers and how they are choosing the products or what kind of profile through our categorical sentence or categorical variables they have. So if we imagine here is some high correlation, we can say that in our data, we can see that most of the people are coming and providing us as an ID driving license, then that another 3 variables are having null value, then most of it's man, he's having mobile word, which is our SA agent basically, then he's having telco operator mobiphone, he's coming for the product audio video, which is here connected with the TV, and somehow we have channel online, the rest it's null, and he is from Saigon, basically the second capital city of Vietnam, and it was online sales through the CD subvention. So categorical sentences, if you will see some reduction 30-50%, which means there will be some huge concentration of combinations of the categorical variables, can be pretty descriptive, pretty informative. But for the hashing, we just use this as a new generated variable. So in other words, we just merged our, I would say like 20 something, like 26 categorical variables to one variable, which is this sentence, and we are going to index it to the hash vector. So please watch the hash example to be sure what is going to happen here. What is the hashing here? And we see that the hashing, what it did, it took all of these as a new vector. So for each customer, instead of 26 categorical variables, we just have one categorical variable, which is a combination for each ID. We have, a unique this combination. Simply we just concatenate all the categorical variables to one, and then hashing take it and index it to the size of the hash vector which we designed by here. I will not spend time in this now, it will be explained well in the hashing example. So let's say that we just set up a priori some dimension of the hashing vector. It is, in our case, it is 45, because Python is starting with 0, so 45. So we have hashing vector size 45, and each of these guys, for each client, is going to be indexed through the hashing function. So it will appear somewhere as 1. Sometimes it can appear as a 2, 3, and so on, which means that the two different categorical variables are being indexed to same value in the hashing vector, same index position. So it will appear as a count, like 2, 3, 4. But it is perfectly okay, it doesn't mess anything. It just means that the variability for the clustering function will be enriched. And how it's connected with one-hot encoding? Oh, it's amazing. One-hot encoding would generate, instead of, let's say, these 50, it will generate 600 columns, new variables. So this is a compression 1 to 10. So compression 10, and which means that you have to have this count. Sometimes 2, 3 will appear here, 5 you see here, which means that different variables are indexed to same position, but it's perfectly okay, it doesn't harm anything. So and now we are using a data imputation, and let's check, as we are using Bayesian Ridge, which is very efficient tool and very quick with a very fine results. So now you tell that we don't have any missing value. Instead of here we was missing already on the beginning, now we don't have any missing values. So we prepare the data, and finally our job finish for the data preparation, and that is we are going to do dimension reduction to really provide a clustering fine set of variables which are pure information, not messy, not correlated, just pure information. And UMAP, it's something very impressive which can really reduce the dimension of numerical variables. As you can tell, we just reduce it to 16 instead of the original 45. And again, even here you can change it, so it's up to you. If you will consider here it is too correlated, as you can still UMAP it's having some high correlation, which means that it is not necessary to have 16, because 16 is here conservative again from recommendation from PCA. When PCA, which is a linear technique, it's able to extract 70% of the original variability from all 45 components or variables, then it says I'm able to extract through principal components 70% of original information with 16 components from these 45. And I'm using this recommendation from PCA, as I call it here, reduction advice, and a priori set up it for UMAP, because UMAP can't do it by itself, this kind of nice trick of what is the dimension needed for the extraction of information. But as a UMAP is nonlinear and it's much more efficient and more advanced than PCA, then actually you can tell that maybe it will be fine enough if you will just choose 10. But for now I will just keep it because we are on exploration, so you can tell how beautifully the UMAP separated already data. And k-means of course see that and very efficiently cluster the data where it should be. So this is very nice job. Select score is something like how properly the clusters are, let's say, assigned. It's 0.6, let's say, around that. So this is nice result for exploration tool. Meanwhile, our segmentation path was done, and it says, based on our statistical decisioning, which is a combination of inertia, which is a variance inside our clusters, and Silet score, which is like the proper segmentation assignment, it's saying it should be around 2 segments. And you can tell, because inertia have pretty interesting decrement here for like first 2, 3, let's say 3 segments, but for the third segment, as k is 3 here, you can see that there is a huge decrement of Silet score. So if you look at the map of optimization path of Silet score, how is changing and why, 2 clusters, which this average is like, let's say 0.16, and here we jump to 0.13, then the reason for that is that from 2 clusters, and here the size is the size of the cluster, and the higher the score of the Silet score for each point, it means that it is properly assigned to the cluster. The lower the score, and it can go to -1, so extreme values, maximum value is 1, minimum value is -1, where 1 means that it is absolutely correct assignment to the cluster, and -1 means it is totally wrong, it should be in a different cluster. That kind of point, because we are on level of points now in our population, random subsample of points here. So you can tell that cluster 2 it's much bigger than cluster 1, that's maybe double, and also you can tell that the Silet score is much more flat, meaning like it is saying, well, you know, it's almost like 0 for the half, it's very low, less than 0.1, and it's like going then very slowly, so there is nothing close to 1 or 0.7, let's say 0.8, which is considered as very good result of the right cluster. Then this result with so low Silet score, it's saying that our data are so different that there are no really clear clusters. It is just huge bunch of things, and it is very difficult to do any clustering for the clustering algorithm. And you can see that reason for the decrement here between 2 clusters and 3 clusters is that this guy, newly generated cluster 3, which is obviously split cluster 1 in 2 segments, is being wrongly assigned, because it's saying maybe it should be in different cluster, I would guess in previous cluster. So hint is the data are not really separable. It means that the variable are too messy for this clustering. So now we are stepping in the world of dashboard, which is the main part for the exploration tool. Why am I saying that? Is that as I highlighted before, we are trying to use the original data, not anymore compressed hashing, not anymore compressed UMAP to reduce the dimension and provide clean data as possible to clustering algorithm, but now we are on the level of interpretation of the clustering. As we are using it for the exploration, then we are now thinking, so what is behind the clusters? So we are going back. Again, we are starting with principal components because they are very easily interpreted through the linear combination of the variables. That's the reason why I'm using it here. So again, we are on some PCB profile of the client, and it says that this blue guy, which is cluster 0, which is also the size of these dots or bubbles, is pretty big, so it's big, yeah, it's 36%. Then it says that it is connected because on the principal component, when you are going from 0 to right or left to plus or minus, doesn't matter if it's plus or minus, but important is it's going to the side, it says that it's somehow correlated with that axis, with that principal component. We know its composition of these guys, so we can tell that cluster 0 is definitely somehow connected with the PCB profile. Then from 0 it's going the green guy, which is cluster 2, and the size is pretty huge too, 26%. And that is saying that we are on the level again here the profile of the client, definitely probability of default, so this is our scoring model, so it is somehow connected with the quality of the clients because it's going again from 0 to plus numbers, right? And also the business design error was the chosen product, tenor, and so on. So we see that cluster 0 and cluster 2 is somehow connected with Great Bureau profile and also pretty highly correlated or connected with the chosen product. I should mention that why we see here 4 clusters, because here, if I jump quickly here, we set up that the minimum chosen cluster, minimum final clusters is 4. It is used as the override, as we use this function and we found the optimal number of clusters, but from business maybe we would consider, no, I need more just to see the data and whatsoever, so it ends here at 4. Okay, so this final select score, it's showing you the final clustering output and how it's affecting the clusters. So you can tell the cluster 2, it's pretty badly assigned because the half of the data points are wrongly clustered. It is either less than 0 or around the 0. And anyway, the rest of the clusters are having pretty low select score, as you can tell here. Like maximum is like 0.3, which is really not a good result. Okay, so let's go back to our interpretation. The guy which I really like is this decision tree, which is saying that what are the main features among all these features which we have in our original data, which can have some pretty important role for the cluster. As we are on the level of the original data, so we see that the most important from the measure of the decision tree, how you can distinguish between the clusters, is actually interest rate. Then it is count of loans which are opened in last 6 months in PCB. Then it is a cross-sell driving license, cross-sell how many contracts the guys had before this application, and down payment, minimal down payment, which it can be seen as proxy for product parameters, and finally again some cross-sell. In other words, it is about product, then it is about basic PCB, and the rest of it is connected if the guy had cross-sell. In other words, if it's new or existing client, this can be seen this way. So if we look at the dashboard again of the as an explanatory analysis, we see that it's starting with the most important variable here is if the guy had open loan within 6 months. If yes, then we going to the left. If no, we are going to the right. So let's go to the left and like explore what is going to happen. So here we see that the most important variable is product parameter interest rate, which can be seen as really proxy covering all the products and their differences. Then it's going to be like cross-sell, like new existing guy, and then it's somehow here is collection, here is again cross-sell, and we are ending on here the purity or impurity Gini is 0.3, 0. Let's say 4, 5, 2. Here, because we are on the Gini of impurity, we are looking for the very low number, ideally 0, which means it will be totally pure cluster. I will explain it on some low number. We will find it here. Yes, here 0.1. So it means that impurity is so low that most likely it will be all about one cluster, and you can tell from the counts, original counts. So this is a count for cluster 0, 1, 2 and 3, in other words our 4 clusters, and the count, it's telling you that basically this node, the final leaf of this decision tree, it's all about cluster 0, as it is rightly stating here, class 0 is this leaf about. So the class 0 and the purity it's so high here, in other words impurity it's so low, is defined the way that the guy PCB candle open in last 6 months is less than 0.7, let's say, and it's false, so it's higher, right? False. Then the affected interest rate, it's less than 0.2, and if you are going to the left, it's true, right? Left is always true, right is false. PBAD, the probability of default, is less than 0. Finally, the insurance is less than 500, and it's true, and we are on the class 0. So it seems like that for this node, the cluster 0, it's these guys, the definition is they are pretty nice guys. So you can really tell from this quick example how efficient it is to explore the super unknown data. From originally 300 variables, we clean majority of them because we consider them as either not stable or like extremely missing, so why to use them, or there are only like one value for the whole variable, so again why to use it. So when we end up on our set of like 70 variables, we now completely understand the quality of the data. The data are about, when we split them to the 4 clusters, that these clusters are saying it is about basically the variable information in your data set. It's about product parameters and some profile in credit bureau. The rest of it is about cross-sell. This is just saying this decision tree. And maybe if you are like from underwriting, you are not really now surprised, but imagine that this data are from unknown department. You have no clue what the department is working about, or like what are the core business and what variables they are using, and now you have just a clue what is the time dependency of the variables immediately within like few minutes, what are the crucial variables which have a tendency to really like hold the majority of the information in the data. In other words, what is the important factors of the department. So I would say for the exploration tool, it's pretty efficient information. And not only that, now we can go to the dashboard of all the variables, and we can see how much it differs across the clusters. So again, now we know that the clusters are defined the way that it is connected with some credit bureau profile, it is connected with the product parameters and the client type. So here you see that the clusters differs, especially, obviously we are not surprised for the cross-sell variables, right? It's like we saw it through the decision tree already. Also the collection variables, it's somehow different across our clusters. Product type, obviously very different here, and it's like having tendency cluster 2 to concentrate very differently. The rest of the guys are about CD subvention, it's the red guy, and the cluster 2 is saying, well, it seems like that there is a different variability, different information. If I like create cluster 2, and that cluster, it's combination of super smart yield, this is how we denoted SSD, the orange it's the CD premium, and the blue low IR. So it's saying these guys are somehow different than the rest of the guys. So we know that the cluster 2 it's so different in the product, we can focus if there's any difference for this, and it's obviously it's connected with the efficient IR, which is much higher here, because obviously we just merge the premium to one group with others. And for the APA variables, if I like quickly screen it here, except this guy and this guy down payment, there is no really from like quick point of view, and maybe here family status is different, but otherwise this guy has a different gender, otherwise it's pretty similar. And this guy cluster 0 is somehow connected with cross-sell very much, as you can tell. It has very different. So now we have a clue that cluster 0 is connected with the cross-sell, but we stated before through the decision tree. And also cluster 2 is somehow connected with a different product type, which is connected with the then after the product is the dictate, right, for the different efficient IR and so on. So another very efficient efficient statement. So it's all now making sense. So these are the top variables which makes the difference between the clusters, and this is the extension of that idea. So the dashboard is always built a way that from the overall look, as we stated before, cluster 0 is somehow connected with the PCB. We just saw it's true. Also the cross-cell, and the cluster 2 is somehow connected with the product type, and we just stated we just saw it in that relative graphs. It is true, it is really different products. So extension, and maybe the most important guy, it's what are the features which are behind each cluster. In other words, if we look at inside the cluster and we compare it how it behaves without cluster and with cluster, we can find the most important or most different variables. And it says for cluster 0, the biggest difference is client type. Then it's PCB variables, and basically that's it. You can if you remember, right, it is totally different than the average population, and that's the reason why the this guy client type is saying is the most different or the most forming feature for this cluster. So these things are really extending the information for us, and now you can tell that what you saw in the dashboard among many graphs here, it's very efficiently determined or detected through a little smart table, which is saying this is cluster 0, it's very much connected with the client type and PCB profile. So if you look at this, you can tell that for the cluster, this is the whole population, which has the basically like 46, 54 new existing, but for the cluster red, it's 81% existing and only 20% new. Okay, so this cluster, it's the cluster 0, it's all about client type, or in other words, existing clients. Then it says that PCB score description, it's all about, like, it's much higher for this segment as a medium, as a PCB score description. Then again, for the segment, it says it is more concentrated on these guys, which means that terminated loans, which means, I believe, because these are the existing clients, that they have already finished loans, and compared to the overall population, which is denoted here as full, the original population without clustering has much higher tendency to have like no finished contracts. It's like purely new clients to the market, right? Then again, because it is existing people, so they have some PCB record. So now you can client type. It's so important for the cluster 0 that it can be expressed or interpreted the way that the client type is an information or variable which maybe has a tendency, once this is true, that it is existing client, has a tendency to affect all the values for the rest of the variables. In other words, the rest of the variability is affected by the fact that the client is existing. And the clustering did a good job in this way and found out that really the variability is so different for this type of client that it has a tendency to collect all these rest of the variables. So again, for the exploratory tool, pretty amazing job. From zero knowledge, now we are on the pretty efficient knowledge. Segment 1, PCB, loan open. So again, this is the most important variable if you look at here. So this is the biggest difference. The higher value here means the biggest difference, and it was the bigger impact to the cluster. And you can tell that it has pretty obvious. Yes, it is all about PCB and somehow this cross-sell, so check it out. So PCB here is the biggest difference. If we compare it with the original population, which is the blue line here, it says that majority is concentrated about 0 or 1 or null, right? This is the original population. But this guy is saying for this segment 1 that actually open loan in last 6 months is most likely for this segment none. It's much higher than the original population, and these guys simply disappeared. Then another information clue is that segment is saying that basically everything is about 1 here for the cross-sell driving license before segment 2. See? This is interesting. So that's the reason why we see it is more concentrated on all the other types of CDs, not only subvention, and compared to the original population. And obviously that guy, when you are merging to one cluster different type of CDs, it has a tendency to affect all of these other parameters which are connected with the business parameters, I mean product parameters like efficient IR, tenor, and so on. So this is not surprising, but nice finding is that this kind of behavior is all about like 80% share its new clients. This is interesting. Very nice. I think we can stop here. It is very clear how efficient it is as an exploration tool, and this is just nice to have, but this is rather for the um, clusters, not the exploration, but definitely the clusters time stability is very important. It's the reason why I kept it so big, to highlight that definitely this must be checked. And the clusters, we can stop here. We don't have to focus now on the out of time because the data are same, so the only interesting thing will be what is the concentration of outliers in which segments. In other words, what are the biggest differences when we look here compared to the out of time sample dashboard. So what are the biggest differences here, for instance, in the decision tree? And you can see definitely there are some, because we kept 10% of the outliers here. We didn't eliminate it, we just detect them here somewhere. So outliers are detected, but it is not eliminated. We are using the trained scaling, and we are using that scaling from the training even for the outliers. So they will immediately show us their power, what is happening and how they are affecting. Once we understand the basics of the pipeline, then we can focus on real clustering approach. We can be a little bit quicker than before, even though that we will now be talking about some economical mechanics of the clustering. So before I run it all again, let me highlight that I just changed the data both for train and test. And first one, training, it's application form for whole 2019 year, and this is strictly only new clients. It is built on their first or end application, but there is one and only condition. These clients mustn't been approved before, which means they are strictly new. This is the definition. And this is the training. So we are going to train on the new client's profile for their, let's assume it as a first application to Home Credit. Then once we train the data and we will derive the clustering for these clients, we will test them how they actually behave in their hypothetical future. And we will do it the way as it's explained in the first basically part, and that is customer journey, which means we will take a vintage, let's say of from January 2018 to March 2018, and we will look at the people who were just approved as a new clients at the time. And as we have 2 years future for these people, because we freeze them at the time and we just observe how they behave in their future in Home Credit for 2 years. So now we can connect it together. We will train it, clusters, for the last market situation, and we will generate clusters for new people. Then we apply these clusters for the new people, but with the benefit that we have 2 years of their behavior in their future. So we can compute things like LTV by clusters, we can compute profitability, we can compute risk performance, we can compute how they are willing to take another loans and what kind of loans and so on. So let's do the real economical clustering. This can be considered as machine learning econometrical exercise. So as the flow is fully automated, we can just run it all and let's do its job. Let's keep the original situation as we discussed, like this a priori setup with the compression hashing and compression UMAP for categorical and numerical variables respectively. the minimum business requirement is 4 clusters, maximum space for statistical testing of the clusters is from 1 to 15, and the rest is same as before, maximum 70% missing rate, maximum 90% for one value in a variable, correlation 90%, and we consider on the training that 10% of extreme values should be eliminated clean from the data to focus on the, let's say, majority common population, not the extreme values, which would affect the scaling. I'm keeping override result 1 because I'm still on development. I'm not sure if I'm going to change something and so on. And my plan is that once this will be done, I'm going to change it here and I will be testing one-hot coding with less categories, and perhaps we can also set no categorical variables and just see how it will behave only on numerical features to have some base and see how categorical variables are going to affect it once we plug it in. Alright, so let's check what we just loaded to the memory. We have 350,000 rows with 40 columns. These 40 columns are mainly, as you can tell, about some F prefix and then APF. So F here states for the profile for the financial institutions in Vietnam. In other words, as we are on the new clients only on the training data and we are on the customer journey, we build the data the way that each row here represents unique ID, unique customer identification, let's call it like passport or anything. And for each ID, we are saying it has to be strictly new guy in 2018, so he hasn't been approved yet for home credit. So he's having, let's assume, first application. So all we can have is the data from the first application, which we are having here as prefix APF, application form data, as a what product channel he chosen, what product he asked for, then let's say what business area he came from, if he has cash loan before and so on. So which is a bank, all the banks. So we are screening also the profile on the bank market. So that's altogether have 40 variables for 350,000 people. What we can tell here is that the daytime decision or time variable, there is not standard way how to format the date. It's able, this flow, it's able to handle it. So let's continue. First of all, we are going to clean it from these 5 excessive checks. Then we check the time stability and we clean all unstable data, and then we clean it the observations from extreme population. First part of this block, data cleaning, is about cleaning these 5 guys, and you can see that 12 variables from 39, because the 40th variable is the daytime decision or date time variable, so we have 39 efficient variables. From these, 12 were removed because of excessive missing rate or not informative value, which is like one value have here 90% of all values or over 90%, and then 2 of them were excluded because they have correlation over 90%, which are these guys, as you can tell from these extreme, these guys, they have correlation 1 actually. Okay, and this is pretty warning because it's already 80% correlation, but let's keep it there because we are using UMAP as the extraction of the information, so it is possible to handle this pretty well. What about time stability? This is the data, and it says that please fix your format and data format fix executed automatically. Then automatically by default we have threshold for our stationarity test 0.1, and with that threshold it was detected that 8 variables from 27 which stay there, we just reduce it by 12 from 39, so we are on 27. So another 8 were removed because they are very unstable, and you can tell that because the unit root, the stationarity test, has its value 0.6, 0.4 and so on, that is extremely high value. So most likely this will be the type product in 2019 to the beginning 2020, very extremely changing its share. It's starting somewhere around 60 or above 60%, and it's for a few months it's going to 40%, and then it's slightly going higher to like 50%, from 60, 20 or less than 20, and then 50. As it is categorical variable, then it means it's a share. It's a share of the major category. And then we are observing that share in time. And you can tell that because it is changing so much, this instability will affect our clustering. It will split the clusters just because it sees some different variability in time. So the clusters will be rather time function than the real business clusters. And this is something which mustn't happen. Then another extremely unstable variable obviously is numerical variable. So this is share and this is the average because it's numerical, and that is for how many loans they have opened living LV at the time of application to Home Credit. So again, something bad happened here because the average was until the mid of 2019 1.2, let's say, and then it suddenly dropped to 0.6, and it from that time it's stable. So here this would directly lead to the fact that again the clusters will be split somewhere, like here is one and here is one, which is nothing we would like to actually allow. Then trend here, obvious increment per every month, basically it's like linear increment from somewhere less than 0.1 ending on 0.25, so let's say 2.5 times higher. And that is for RN, stands for cancel. So how many cancel loans this guy had before he joined or applied for his loan in Home Credit. Finally, this guy, it's unstable too. This is not that obvious, but it's starting on like 0.8, then it's dropping down to 0.6. But this one, maybe we can keep it there. This one from 0.1 or 16 to 65, so this is extremely unstable, obviously. This is very similar shape as these two, and it's not surprise because this is product channel and this is type product, so these are correlated categorical variables, 1-to-1 almost. So if we can measure correlation between these shares as we can, it will be very high correlation. So these two are definitely not stable. This is again some structural change. It's from 0.4 going to 0.6 stable, and from here it's considered stable. So maybe we can play with the threshold and set up the threshold to, let's say, 0.25 or something, to keep these guys, the group status and sales business area, if we want to. And but for our exercise, let's keep it a priori as it is, because the rest of the variables, all of them are pretty informative, and we kept the F group still important. So we have these which are nice and stable. So let's eliminate these 8 and continue with 19 variables. Outliers, 10% by definition. Oh, we can tell that there is a huge correlation with this axis principal component 1 for these outliers, who are denoted here as red dots. And that is all about cash loans, as you can tell, or at least the F status. So this is the linear combination of the variables, and these are the biggest contributors, these 3 from our 19 variables. And you can tell that there is something about these guys are having cash loans, I would say, and most likely they will have some big loans. So we just eliminated these guys for high values of loans in credit bureau to don't affect our scaling and the rest of the population. Categorical transformation we just generated, and this is very nice. If you watch the previous part of exploration, using the pipeline as exploration, there was the reduction 0. Now the reduction is 90%, and the reason for that is because we have significantly bigger data. Before we had 10,000 observations, now we have 300,000 observations, and the dimension in the data, it's not 300,000, it is only 20,000. The reason for that is that there are high concentrations of only few combinations of merged categorical variables. So again, like 1 second recap, we merged all categorical variables which we see here in to one variable, to new one merged variable. So we have, instead of our x categorical variables, we have just one categorical variable, which we can denote as categorical sentence. This categorical sentence has pretty high concentration, as most of the guys have telco and they don't have credit bureau profile not found, and they are men. And that is very high concentration here, right, in our data. The another high concentration is other, and just same. Then it is for women, and so on. So these concentrations actually are saying there are extreme correlations of our categorical variables. And in this case, using one-hot encoding will be total disaster, because it will just create, very sparse zero data. Like most of the variables, binary new variables instead of categories will be just zero, very sparse data, and majority of it will be extremely correlated. Extremely correlated because you see that many IDs having just same values. So that is a great that we a priori use hashing, and we can tell that the hashing just created 10 classes. The dimension of the hashing vector is 10, and that is very good news, because then we can see that it's not that sparse, that you can see some counts, 5, 4, and so on, which means that the original variables, let me check what is the original. So we have 9 columns, and the original variables are APF. Like 9 categorical variables, and we have APF education, APF family status, and so on. And the APF education have these like bachelor, elementary school, and so on. And we will take that variable, and like for each row, for each ID, because we are, as we stated, we are on unique IDs, so each row here is a unique client. Then we will merge these all 9 columns to one new column, and we will call it categorical sentence. And then we can use hashing as an actual language processing and say, please use the dimension of D, which we said it's dimension 10 by this function. We will talk about it in the hashing example in the next session, and statistical session, and index it to your hashing vector of the dimension 10. So I'd use it for the, as I stated on the panel, I kept it once, which means I'm going to use transformed hashed variables, categorical variables, in the imputation of missing of numerical. And I'm going to default choice is Bayes enrich, which is a different basically type of linear regression. I would call it more convenient, and this is the default choice. You can change it if you would like to random forest, but be please aware that it's much more computation and hard disk space demanding. And we already imputed all our numerical variables or features, and you can tell that there is 0 missing here. As you can see, this is obviously imputed. Okay, nice, we are ready to do the very last step, and that is something which we did for the categorical variables through hashing as a reduction. Now we are going to do that with the default choice UMAP, and we are going to do the reduction of the categorical variables, as I stated before. Now, the recommendation from the PCA is saying that 70% of original information in the dataset it's explained with just 5 principal components, and that recommendation was set up here as a default choice. From these 10 we are efficiently going to halve 5 based on this recommendation for linear principal component. And again, a quick recap here, as we discussed in the exploration part, that PCA is used here as a maximum threshold, as it is linear technique which is extracting original information, original variability of the dataset through principal components. And once we see that principal component PCA it's able to extract, let's say 70%, in this case 77%, through some number of principal components, we are saying that can be considered as the maximum threshold, maximum value dimension for nonlinear, much more advanced and efficient techniques with unique information extraction from the dataset. So this is the logic. Now UMAP already did the job and used this recommendation of 5 and extracted 5 new UMAP values or vectors. How it did the job? Now we have a little insight to generated reduced variables, and that is saying that the correlation is pretty low here. Also it says when we run only on these numerical reduced variables, this UMAP new vectors, that it is pretty nicely distinguished, right, by the k-means. It's created. The UMAP allows us to really create a new view to the data, and that view k-means very clearly see and saying with this is Silet score it's above 0.6 and it seems pretty okay. So I would keep it as it is because I don't see any high correlation of the UMAP variables, and we can efficiently go for 5 numerical variables UMAP and 10 hashing categorical variables. So we have in total 15 variables which are going to be plugged to the clustering. And based on the clustering, it says that basically the optimal number of clusters is somewhere around, I would say, from 3, and this is depends on your taste. It can be 3, it can be 6, it can be 4, 5, anything on this part of the curve when it's still pretty like exponentially decreasing. Definitely it is nice. I try to derive a function which is like doing smart exploring of the shape of the both two girls here, inertia and the Silet curve. So first, the inertia is the variance within the clusters, which means that when you have no clustering, which means k is equal to 1, as you can see here on the very left there is value 1, and there the variance of the population is some 640,000, the variance. Now if we split it to 2, the variance, which is now measured inside two clusters, immediately decreased to 450. Then when we split it to 3, to 350 let's say, and so on. Now I'm exploring this by some function. When I find some optimal point, when I can tell yes from this point and this point has a different slope significantly, then from that point I'm exploring the Silet score and I'm asking what is the highest future like forward Silet score, and I'm exploring 4 another clusters forward because this choice, these 3 are pretty conservative point to cut. Okay, so I'm conservatively choosing points somewhere here based on inertia, and then I'm exploring 4 further clusters and I'm checking their Silet score. And these clusters, this cluster 1 and all these points are very well, they are very comfortable inside this cluster. They like that cluster. All the points regarding their profile, regarding the center point of this cluster. Also something similar we can tell for cluster 0, even though the one is slightly better. Not that good news is for cluster 4, 2, and 3. So still it is like reaching 0.5, so average Silet score is 0.46, but some part of the points in our data can be actually assigned to different cluster. And that is the last part of that decisioning here, to try to minimize this part. Okay, so let's check what is the optimization path by the Silet score from K2 to 15. So you can see that for cluster 2 and 3 we don't have any negative points, and actually here 53, this is same, and this is 47, then 50, it's again increasing, 53 and even 58 and 53 again, and I believe from this point now it will be decreasing extremely. Yes, 42 and up. So why is that? Now please keep in mind that for the computation efficiency I need to stay on some reasonable sample, and that is I'm using 3000 observation points for each run of the 10 runs, and this is just the visual for the first run. Okay, so this value can be kind of volatile, but the decision maker is the bagging, which means the average over all 10 runs. Was said it is for number 3, it's 53.5, here it's 52, and here it's cross dropping to 48 and so on, and then it's increased to 57 for 7 clusters. So it should be correlated what we see as an average, which because this is the average over the bagging, but not necessarily exactly same values. But anyway, we see the similar behavior, slightly increase, then on 4 clusters decrease, and then it is increasing again, and 7 clusters have the maximum value. So it seems like that 7 clusters would make a lot of sense for us to set up it here. So maybe with this knowledge we can go back to the user input and set up here that actually I'm willing to have 7, and that will override the result. As we chosen before that minimum value is 4, it is not really like lucky choice, because that is actually the lowest. As you can tell, this is the local minimum here, right, among these guys. The absolute minimum, the global minimum is here and the 15th, but the local minimum among these between 2 clusters and 7 clusters is actually 4, which is our business choice. As I would say, the inertia is still decreasing, and it's like reasonably decreasing even until 7, and it is as high CLS score. I would say this is my analytical choice, even though that would be the choice. Now we are going to the dashboard, and as I mentioned, dashboard is here that it is trying to get on the original values as soon as possible. So we said that we are using 5 UMAP numerical features, decompression, and we are using 10 compressed categorical features. Okay, that was used to get the best, let's say, predictor space for the clustering. And now we are going back to our original values because we would like to interpret these clusters which we just found. So we scored all the populations, or our 300 guys, and we let's join it back to our original data. Thus, we can look at the original data's behavior with newly cluster identification. First of all, we're starting that it seems like that for these guys which are going to the right or left from 0 on the principal component, it is important this feature, class 6 and class 1. As principal component analysis can't handle categories, I can't show here the original categorical variables. That's the reason why I'm saying here that for the first 2 dashboards or first 2 graphs, I have to use the categorical variables transformed. When it's as soon as possible, I'm using original values. So numerical variables having always the original values, and here we see the hash vector. So is there any interpretability? Perhaps not much. Now for the interpretation it would be better one-hot encoding, and that's the only downside of one hashing, that is for these 2 guys we can't really interpret what that means. We just see this cluster, it's depending on some classes, on some categorical variables, and it is also connected with non-HC finished loans. But don't worry, once we will start with these 2, they will discover it because they are using original categorical variables. So we will be even able to interpret what class 6 and what class mean, because we will see that as it is important here, it will be important here, and we will see it on original categorical values. What about this green guy who is like going to both sides from 0 on PC3, which is cash loans? So obviously the green guy, the little number 2, which has 20% of the population, it's heavily depending on either have or not have cash loans. Obviously, I think this will be seen later. Okay, another obvious point that there are some values which having tendency to be correlated with PCA 8, which is application for main income, or number of how many applications he actually had before he was approved, and how many times he was rejected. RF stays for rejections in our competitors. So I believe these guys are having a high value of trials in home credit. They are always rejected, and also in credit bureau report they are most likely rejected, and I think that will be somehow correlated with main income. This is just my guess, and it is pretty affecting this blue big dots, which is class cluster 0, 32% of the population. Alright, so let's check it out. What is the most important variable from the point of the decision tree? So it can pretty efficiently explain the reason why some clusters are formed, even though that keep in mind that we use for the clusters the reduced variables, the UMAP and hashing. And now we are using for the decision tree the original values, right? Except, you know, the categorical variables are still on the hash, but the numerical are on the original values. And you can tell that basically except one, the most important feature for the decision tree, how to distinguish between clusters, everything is numerical variable. The most important is how many applications the guys have, which means, as I stated, these are strictly news, but they can have many applications and never be approved. Then another one is how many finished loans, TM states for terminated, but actually it means like finished loans they had before they actually applied for the loan in Home Credit, then how many children they have, and how many, or if they have any cash loans in our competitors, and also how many times RF states for rejections. So as we have a pretty good economical insight to the data, as I'm highlighting here, this is must for proper clustering, then you can tell this makes a lot of sense. The clusters are, we can check the distribution guy. On the very beginning, we starting with our clusters, which are just split to what we saw before, for 0, 30%, and the rest having approximately 20. Then he have just first application only, or he already is having his second, third, and so on. Anyway, the majority is just standing here. So if he just having his first application, meaning it is smaller than 1.5, in other words, is 1. And obviously number of applications can't be 0, so there is either 1 or higher than 1. So now we are on value 1. Again, we have to have good economical insights if we are running clustering. So the guy is open cache loan, F-node cache loan is open, then we end up on cluster 3. And so this is a perfect definition of cluster 3. Strictly new guy, either to the market or simply was rejected before. He doesn't have any finished contracts, he doesn't have any baby, and he has open cash loan, and this is cluster 3 here. Cluster 3 appears also here, but that count is 200 and this count is 40,000. So this is definition of cluster 3. Another significant cluster 3 here, you can tell by the color of this, is this guy 10,000, and that is that he has a child or children. Maximum number of cluster 2 is this another 30,000, which is very significant. New guy to the Home Credit who is not new to the market, he has some finished loans already. And then it's fine, that's the only one which is strictly defined on the right side. So these guys are having more applications which were rejected before. The rest of the guys, cluster 3, 0 and 2, are all with just one application, first application to the Home Credit. That's the whole left side here, and then we split it. The right side is that these guys already had some applications before, but they never were approved. And now the cluster 1, the significant part, is defined the way that these guys don't have open cache loan, because we're going to the left, right? It's higher to mention that these variables are from here. So the most important variables are immediately shown here. Only for now we are on the level for this relative distribution, features distribution by clusters, and now we are on the original values for both numerical and categorical. So I'm showing only numerical because this is the overlap, right? Okay, and that the rest, all the variables can be seen here. So now we are on the original categorical and numerical variables by the relative distribution by clusters. So education is very different, you can tell. Obviously, as was stated before, the number of applications, this is something which we saw before here, right? This is the very crucial part which is distinguishing. If you look at the age, except cluster 3, I don't see really huge differences. Cluster 3 is obviously young people, because the blue, it's, you know, you see that it's pretty young people. Also, the oldest guys, it's not surprising, is correlated with the number of children. They have, you know, some children here for the orange and green has the biggest share here. So these are the cluster 0 can be stated as a families. See that, right? And cluster is definition for cluster 3, and they are also the youngest guys, which we just said. So these are the newbies. Cluster 3 are the newbies to the market, young people. Cluster 0 are the families, and cluster 2 is active players. And what about cluster 1 then? I don't really see extreme pattern here. Like I see this, which is that overall credit bureau profile of our competitors, and cluster 2, as we just stated, are active players, obviously, with majority of already finished loans terminated. And cluster 1, it's kind of active. That is definitely difference between other clusters, but more than half of these guys are having null, which is connected with the PCB hit. It is, you know, not found, and the rest is found. So it's like mixture between people who are already on market and who are not. The rest of it, it's really mystery for now, so we have to use our powerful guy as the last detective story, and that will be the features forming cluster. And as we already pretty well understand 0, 2 and 3, so let's focus on 1. And again, not surprising, right? The 1, it's saying the features forming cluster that high HC applications is the biggest crucial value which is forming this cluster. Then cash loans, so this is similar to the decision tree, and obviously this will be 0 because they don't have any cash loans, as decision tree told us. And another things, it's again, this is similar to decision tree, but honestly I wrote this algorithm, it is not connected to decision tree. I was just thinking what will be the best way how to describe the cluster based on distributions difference, statistical distribution difference. And the higher the value, the more the distribution inside the cluster is different than compared to the population distribution without clusters. And you can tell that, so if we look at the dashboard to cluster 1, so yes, this is what we know. They have like, now at least we see it clearly, 34% of the people have more than two applications. That's basically the major difference, because the rest you can tell it has very similar shapes. Comparison between full population, which means without any clusters, and the segment inside the cluster. When we look at another clusters, you can tell the difference is much more clear here. It is like telling you where it's coming from, right? That's not lying on each other, these two populations. But cluster 1, it's really like very close to the original population. But this is something what we have here. Maybe if we split it to 7 clusters, this cluster 1 will disappear. Because simply, as we saw before, we have some issue with decrement of the SILET score. So through this, and what is this orange guy? That's cluster 2, which is increasing with this PC3, which we saw before. And that's the cluster 1. It's really the almost like original population, when it's like, you know, here in the center. That's like 4. We were able to pretty nicely distinguish 3 clusters very well: families, active players, and newbies. And it is stable in time, should be, as we eliminated unstable variables, so everything worked well. Now, so economical reasoning, I hope is very clear now. I would like to just highlight that we designed the data the way now, testing data, that now we are on the vintage of the approved people who were new, who had this exactly same status and data profile in the beginning of 2019. As we are having data until the first quarter of 2020, we have actual 2 years future of these people. So what we did, we calculated exactly same profile, exactly same variables with exactly same definition for the guys who were new in the beginning of 2018. Then we freeze it, and then we observed how they behaved inside the home credit on their customer journey. So we are still on the unique customer ID. So this data is having same structure as this data, but here we just keeping only approved people. So let's do it. Let's see what underwriting did for us, and when we go to the out of time sample, in other words this historical vintage, and we see the future of this vintage, how they behave and how it's changed the actual clustering. So as we already are using our trained variables, the clean outliers, we just detect them, don't delete them this time because we are on the real production approved people. So this is the purpose of this, how this will behave on the real production, the clustering. We are using the same procedure. Now these guys are approved, so you can tell this kind of sentence, categorical sentence, has slightly different profile. And that makes sense because the underwriting did the job, did its voting and said, let's say 20-30% are rejected and the rest of the guys are approved. And you can tell just by this what is the effect of the underwriting, that suddenly we are preferring married people because these are the highest concentrations. Obviously we do, because they are more stable. This is our scorecards effect. They are employed, again effect of underwriting, and they have higher education, again effect of underwriting. So I think once we understand the mechanics of data and how underwriting works, just these little clues can tell us a lot about our underwriting and scorecards. Okay, so we transform it exactly to the trained hashing function and trained cleaning function. We apply it, so we transform the data, we impute it by the trained imputation function. Standardization, again we standardize it by the trained standardization values. And now we use the numerical dimensional reduction by the trained UMAP. And finally we have our final data for clustering. We apply the trained clustering and we have our clusters here, as you can see here. And newly we have new column outliers, which is detected but not removed outliers on the test data. Okay, so I believe this part, it's all about the dashboard, right? Because we just apply all the trained and store functions. And I would like to highlight again that this is one-to-one production workflow. So if you copy or just copy paste this whole number 7, this whole block, then you can use it on your daily production because it will automatically read all the stored models, fitted models from the training, and score your daily production or hourly production. All you need to do is just run it through Python. So the effect of it is that it will extend your data by 2 new columns, segment ID and detection of the outlier 0 or 1. And this is very nice because we will see what are the concentrations of the outliers by segments. I will do a jump little bit over, I will come back, but let's go to see where are the concentrations of outliers. We will do it through feature distribution by clusters. Click on it and outliers are at the very end, and whoa, you can tell that actually all the outliers are being concentrated in cluster 2. The rest of it are basically without outliers, but all the outliers are in cluster 2. What a surprise, honestly. This is interesting. But on the other hand, it is very consistent because remember that we said that outliers are very connected with the PCB extreme values. And look at this, cluster 2, it's defined by the found in Credit Bureau. So actually outliers, eliminated people from the original train data, are all the people who had the extreme values in Credit Bureau. That's the thing. So now we are saying that these guys are now assigned to the cluster 2. And I like this very much because it is like a clue for the business people or for any communication. It doesn't mean to exclude people, not at all. It means that just to apply a different strategy for them. So now actually we have 5 clusters. We have original 4 definition of clusters, and now we can split cluster 2 to 2. Extreme values and standard population, and we can apply different strategies. So this is the purpose of this. It says that definitely there are some connections for, again, the green guys, cluster 2, with PC3, which is again Credit Bureau profile. So this is not surprising anymore. Now we understand why. And the rest of it, I think it's pretty similar. But I'm very always curious what underwriting did with size of the clusters, because this is a direct statement about what our underwriting prefer or what home credit prefer. It's amazing to compare what is the incoming population on the application level and what is actual approved contract, and this is what we do here. Now we are the sample, as I said, it's all about approved contracts, and training sample is all about applications, and everything is on the unique level of IDs. So we don't mess up by some counts on anything, we just properly train clustering for the application distributions, and now we applied exactly same applications but filtered by the underwriting. So let's check what underwriting with respect to the clusters prefer. So the original distribution was dashboard PCA. So it's 30, 26, 2020. So it's easy to remember. 30, 26, 2020. So dashboard here in the test is, so this is same 30. This was 20 population that it will have average approval rate, and that back in 2018 was on average 80%. So these guys, number one, as they have an average profile, will have approval rate 80%. So that's point number one. So from originally these 27%, we approve 80%. And then for 2 and 3, because these guys are pretty biased clusters already, like clear to describe, we are saying that will not definitely have average approval rate because it's lower, so it will be less than 80, it will be like 70 or 60, and this guy will have even lower because that goes to, I think 12 is there. And we said that cluster 3 I think are newbies, if I remember right, and cluster 2 are active guys, and that make a lot of sense because we don't really like newbies without the job and young people. So when we look back here, cluster 3 are newbies, are young people who are having here, they don't have any merit status, it's either null or single. So, and they are mostly rejected. So now we see the effect of underwriting. So we are saying the job, we don't months in work, they are young and they are single. So we reject them the most. Then the second hardest rejection is for number 2, and we know these are the already active people on the market. So we reject them because we have that extra information on Credit Bureau, this is my guess, and plus I think we see this green, so we definitely will reject anybody who has delay in Credit Bureau. Also they have zero, I would say these are, we will like them because they are married, they are families, and 0, what is the effect of zeros? 30, and so they keep same, so I think we like them simply. It's the underwriting doesn't do much with them because they keep the same share basically. Okay, so this is clear. So this guy have some, let's say, higher approval rate, and these guys, new guys, young guys, rejected the most. Second, active guys who have Credit Bureau, heavy Credit Bureau profile are rejected based on their activity, and the rest of the guys. It will happen when we train on the customer journey data, when we create a segmentation based for new people, and then we apply the segmentation of the production. And obviously on production, what we care about are approved people, right? After the segmentation, after the underwriting. So this is what will be the actual most likely share, and we now understand the reasoning of that. Young people, active people, families, and some average population, which so it's coming stability inside portfolio, and it's stable, extremely stable. How it looks like, similar, very similar, which is a good news. We shouldn't see extreme differences through the effect of underwriting. So, and now that will be another video. That will be what we will do is that we will score 2 vintages. So I just scored and stored this design, and I will keep it this way because 4 clusters are easy to read. So what happened here, when I look at here to output and score data, what I see here, it's the training sample was just scored, and so it's extended original data by k-means, by the clustering, and that this vintage to 18, the test was scored and extended by the segment and outliers. So this is what I have here as CSV files. So I will score one more, and that will be vintage of 2019. I will just run exactly the same setup this, but this time I will change it here to override 0, 0, because I don't want to fit. I just want to run this test data with this test data, exactly same setup, exactly what I fitted to be comparable between vintage 218 and 219. So the difference here is that 219 are the people who were approved on the very beginning of 219, and I'm looking for their future of 1 year behavior in home credit for the rest of 2019 and beginning of 2020. And I'm doing that because I can score them meanwhile. So I will go here. I can just select it all. Just to check how it will behave until here. And we can run it. So now it will score the vintage of 219. And thing is that then we can compare, because this Business Insight is built the way that it's always comparing two vintages. As you can see here, I'm saying please fit at store two clustering models or setup or test samples to compare, because I wrote it away to always compare two different stored samples, or it can be two different designs that one time you run one hot encoding, second time you run hashing, and you are comparing it on one test sample, so the Business Insight can give you immediately answer how that have effect on the business statistic. Or you can do it the way, second way, which is I'm using two different vintages and I'm checking how they differ with respect to the time. It will give you a lot of sense if you watch the blog 1, the customer journey videos, because I'm justifying this approach there. I will, if you don't have time to watch it, I'm just give you a quick insight that the reason for 219 here is because that we would like to see the actual market situation on the credit bureau. So 1 year max, something like that. So I would like to see how they behave with respect to the current production. So I would like to check their behavior, what will be the share of the clusters, what will be the credit bureau profile, and so on. And then I will compare it to 18. And if I will see some stabilities, I would consider that can be a production clustering, if it has, of course, business reasonable statistics and so on. And the final is that what we are going to do in the next session, the Business Insight will run this SQL script, this guy. This SQL script will run on our scored CSV files, and it will simply group by our 4 clusters, and it will calculate all these statistics like LTV, LTS, eligibility, acceptance, share of the products, type of the products, credit bureau profile, credit bureau hit, and so on. So it will give us the insight what are the business statistics for each type of the clustering. Okay, so I see you in the next session. Thank you very much for this huge video. But as I try to divide it to 5 parts, I believe it is manageable and you can simply per part test enjoy it. Alright guys, see you soon.